Example 4. A line intersecting the circle x square plus y square equals 45 at the points P, -6, -3, and Q, 3, 6, has an equation y equals x plus 3. Chord PQ measures 9 root 2 units. OR is perpendicular to PQ. Center of the circle is at the origin. R, -1,5, 1,5, is the midpoint of chord PQ. A, -15, 15, is the point of intersection of the two tangents P and Q. Proof that PA equals QA. Determine the equations of the two tangents to the circle, both parallel to the line with the equation y equals 2x plus 6. Let us determine the length of the tangents PA and QA using the distance formula. dPA equals root 405 equals 9 root 5 units. Similarly, we can determine the length of tangent QA. dQA equals root 405 equals 9 root 5 units. Hence we say that PA is equal to QA. Let us draw a rough sketch. Recall the gradient of the parallel lines is equal. The tangents to the circle, parallel to the line y equals 2x plus 6, will have the same gradient as that of the line. Therefore, m equals 2. Let us mark the points of contact of the two tangents as S and T. To determine the coordinates of S and T, we need to find the equation of the line perpendicular to line y equals 2x plus 6. This line passes through the center of the circle and intersects the circle at S and T. Gradient of the perpendicular line ST equals -1/2. Since line ST passes through the origin, using gradient point form, we can determine the equation for the line ST. Therefore, y equals -1/2x. Since this line ST lies on the circle, it will also satisfy the equation of the circle. Taking LCM of the terms on the LHS, we get, multiplying both the sides by 4, we get, dividing both the sides by 5, we get, x squared equals 36. Taking square root of both the sides, we get, therefore x equals plus or minus 6. To determine the y-coordinates of S and T, we substitute the value of x in the equation. Therefore, y equals -1/2x, where x equals 6, y equals -1/2, times 6 equals -3. When x equals -6, y equals -1/2, times -6 equals 3. Now to determine the equations of the tangents to the circle at the points S and T, we use the gradient point formula. Equation of the tangent at S, 6, -3, parallel to the line y equals 2x plus 6 is, substituting the values, we get, therefore y equals 2x minus 15. Similarly, the equation of the second tangent, parallel to the same line passing through T, -6, 3, can be found. Therefore, y equals 2x plus 9.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you, and let the math finally start mathing.